Hey, welcome back to the project. So let's continue our discussion. Okay, so now we have just installed CubeMX software. Now what we'll do is we'll just create one project. Okay, so what you do is just click on new project. Okay, so when you click on new project, you will get this a nice GUI where you can select your microcontroller. Okay, so let's just click on this board selector here so that we can select our board. The type is Nucleo 64. Okay, in my case. All right, and in your case just select the suitable option. If it is discovery board, then select discovery. If it is Nucleo 64 board, then select that. Okay, and MCU series, I have F4. Okay, and mine is this one. Okay, so suppose if you are having, let's say, STM32 discovery, then select discovery F4. And I also have a discovery board that is actually this one. Okay, 407 VGTX. Okay, so I also have this. Okay, but for this experiment I'm using Nucleo 64. Okay, so I'm just selecting my F446RE board. Okay, so I'll just double click on that. All right, so after that you will get this window where this is your microcontroller chip. So now what we'll do is we'll just generate code. Okay, so for that, go to project and click on settings. Okay, and here just give a name for your project. Okay, so now let me just give a name. I'll just give a demo project. Okay, so just create one project, demo project. Okay, and the project location. Okay, so location we'll choose from here, our workspace. In my workspace I'll just create one folder called CubeMX projects. Okay, so I'll tell you why I'm creating these projects, okay, in a moment, don't worry. So I'll just select this path. Okay, and I'll go back to my CubeMX and I'll just paste this. Okay, so here I'm creating one demo project. Okay, so now after that select this option SW4 STM32. Okay, after that, okay, come to code generator. You can select this one, copy only the necessary library files, no problem. Okay, and okay, and all these options keep it as it is, don't change anything. And after that just click on OK to save. Okay, and after that go to project and click on generate code. Okay, so it is generating code for my Nucleo board. Okay, and now click on open folder. Okay, so these are the outputs generated by the CubeMX auto code generation software. Okay, so now here you can see drivers, right? And you can see here KIMSYS drivers. These are KIMSYS code drivers which we saw here, right? And these are the HAL driver. That means this part, device HAL. So in order to get this, I did all these things. All right, so this is a source. So these are all the HAL drivers. It is not having all the drivers. Remember, it is not having all the drivers. It just has the required drivers for this project settings. So because in the settings I have chosen copy only the necessary library files in order to work with these enabled components here. So like setting up your clock, turning on, turning off some of the GPIOs, which is, you know, driving your LED, etc. Okay, so if I click on copy all used libraries into the project folder, then all the peripheral libraries would have copied to this location here. Okay, so but okay, that we'll see later, so let's not worry about that. Okay, so what I wanted you to understand is that this is the output of the CubeMX, and in the drivers folder we can find out these two important layers which is required for our project. Okay, so one is the HAL driver. Now what you do is go to source, copy everything into your Eclipse project. Okay, go to STM32F4XX source. You have to go to source and paste here. All right, and after that go to include, copy everything. Okay, you can even copy this legacy also. Okay, copy everything and paste here, okay, in the include, right? Great. So our HAL library is populated. So now KIMSYS core, this needs to be updated because, as I said, KIMSYS 5 is out. Let's see what CubeMX is using. Go to KIMSYS, include, and open this one. Okay, it is still at 4.3. okay, so that means ST has not updated yet. So that means we have to use 4.3 only. Okay, great. So copy everything and paste here in the KIMSYS folder. Okay, paste. It will ask that, so it will ask to overwrite. Okay, click yes to all. Okay, so all are updated with the latest. All right, great. So now what you have to do is come back and go to KIMSYS device. Okay, and go to STM32F4XX and click on include, and you need these 3 header files, system header files. Okay, so just copy this and paste in this location. Okay, in the include KIMSYS. Okay, paste. Okay, great. So our 9th step is completed, that is download and populate MCU peripheral drivers from the silicon vendor. The way we did it is using installing the CubeMX software, and by generating a demo project we located all the KIMSYS as well as hardware abstraction layer, and from there we took those files into our project. Okay, all right, so after that in your demo project, okay, you have to go to include and copy this HAL configuration file and go to your project and under include, okay, system include in STM32F4XX, just paste that. So you should be having HAL_conf in the beginning. Okay, all right, so after that you have to make one more change. Okay, so go to system source and just open KIMSYS. Okay, and here you have to replace this file vectors_stm32f4xx.c with a more microcontroller specific startup file. Okay, so this file actually contains a vector table. A vector table is actually the collection of function pointers, or you can also say that it's a collection of addresses of different interrupts as well as system exception handlers of the microcontroller. Okay, so don't worry more about this as you make a progress in the course. Okay, when we are going to develop different drivers for GPIOs, SPI, I2C, etc. So you will come to know what exactly is an interrupt handler, what is IRQ number, how to locate vector table information from your reference manual of the microcontroller, etc. Okay, so you will learn as you make a progress. So in the beginning, let's not worry about that. Okay, so you must know that these handlers are actually called by the processor when the corresponding interrupt or system exception hits the processor. Okay, so you have to program these addresses in the vector table space of the flash memory of your microcontroller. Okay, so the Eclipse project has added this vector table file, okay, for us, which is kind of generic to the ARM Cortex-M microcontroller. Okay, so what I suggest is go to your demo project which you created by using CubeMX project. Okay, so under that you will find a folder called startup. Okay, so just open that and you will find one startup file which is actually an assembly file. Okay, which is specific to your microcontroller. In my case, my microcontroller is F446RE microcontroller, okay? So that's why the CubeMX project has created this one for me, which is more specific to my microcontroller, okay? In your case, if your microcontroller is based on, let's say, STM32F407VGT6, okay, then you would find a startup file which is more specific to your microcontroller, okay? So it is always best practice to use startup file which is more specific to our microcontroller, okay? So in our project, the Eclipse has already added, okay, a startup file which is more generic to Cortex M based microcontroller, okay? So but it is not specific to our microcontroller. So I think it is best idea to replace this file, okay, with this file, all right? Because if you open this file, okay, which is there in your CubeMX generated project under startup, okay, so if you open this file also contains a vector table, okay, so which is more suitable for your microcontroller. So what we're going to do is just delete this, okay, and instead of that use this, okay, right click and delete this, okay, and just copy this and then paste under source schemsys, okay, system source schemsys, paste. All right, so after that you can see that the extension here is .s, right? So the .s must be in capital letter, okay? So because the Eclipse expects the assembly file extension must be capital S, okay? So we have to rename here, all right? So for that, just right click on this file and select rename, okay, and instead of small s, just make it as capital S, that's it, okay, and then click OK. So we just changed the extension to capital S. Okay, now let's try to compile this code, okay. So before that, we have to do a couple of settings, otherwise our compiler will issue errors, okay. So first of all, let's go to system. So include STM32F4XX, okay, and open this HAL conf. Since this is generated from the CubeMX project, CubeMX actually attaches this header onto this file, okay, inside this file. So just remove that, include main.h, okay, and just save it. All right, and this HAL configuration file, as its name indicates, it's a configuration header file for the whole HAL layer, okay. And here you can see that only the required HAL modules are enabled. So in this project, only GPIO, DMA, RCC, Flash, PWR, Cortex modules are enabled, okay. If you want to enable, let's say, UART, then you have to uncomment this option. Which option? The UART option here. You have to uncomment that, and you have to add that driver here, okay. So that we will see later how to do that, okay. And if you want, let's say, spy module, then you have to enable this macro and you have to add its driver header file here and the driver source code here, okay. So like that. So whenever you add a module in the HAL conf, you have to add its corresponding driver here and the header here, okay. So for that controlling, this configuration file is used, okay. So now after that, what you have to do is, you can see in this file there are lots of if defs and end ifs, okay. So that is this header file is actually used to fine tune your entire HAL layer, okay. All right, so now one more settings we have to do, that is go to system, okay, and open up include, open up ChemSys, okay, come here and go to STM32F4XX.h, okay. So this is the main header file, okay, or the top level header file, okay. And here you can see some macros. It will enable various microcontroller specific header file based on these macros, okay, or you can call it as a preprocessor directives. Okay, so for example, in my case, my MCU is based on STM32F446RE microcontroller, so that belongs to this family. Okay, so that's why I have to enable this header file, okay, which is present here. Okay, so for that I have to define this. Now if your microcontroller is based on, let's say, F405 family, then you have to define this macro. Okay, so now the place to define that we should know. Okay, so what I do now is I copy this name. Okay, I'll just copy this, okay, because this is a macro which we want to define in order to define this include, okay, because it is not highlighted, right? So now what I do is I will click on this, right click on this project, and I will select properties, and here in C++ build, just expand this and go to settings. Okay, and here click on this, okay, ARM cross C compiler. Okay, and click on preprocessor. Okay, click on preprocessor, and here you can see that these are the defined symbols. Okay, and now let's define another one. Okay, just press here plus, okay, and paste whatever you copied. So what we are going to tell our HAL library is that my microcontroller belongs to this family. Okay, save this. Okay, great. So this is a very important step. So now after that, click on apply, click on yes here, and okay. So that's the important step you have to do. Okay, so let me write that step 10 here. Okay, Eclipse project settings for your microcontroller. Example, if your microcontroller is based on STM32F406XX family, then define this macro as the processor directive, okay, in the project settings. Okay, so you have to do this. Okay, so now let's go to our project. Okay, all right, now let's build this. Go to clean project first, okay, and then right click and select build. Okay, so now the project is building. I hope this builds properly. Okay, there are a couple of warnings we need to check. Great, so I'm very happy that the project built successfully, and you should achieve this. Okay, and there are a couple of warnings. Let's see what are the warnings, because warnings are always dangerous. Okay, this is for unused parameter. That's okay, unused is actually harmless. This is also for unused parameters. All right, so those are for unused parameters which we can ignore. Okay, strictly speaking, you should handle those unused parameters, but this is at the driver level. I strongly discourage editing driver files. Okay, fine, the compilation is successful. Okay, so our step 11 is compile the Eclipse project, and it must be successful.